Hello, dear all. How are you? I think you're fine despite this difficult period, and I think you are ready today to, let's say, to participate, to follow this interesting lecture, interesting webinar that we are going to have together. It's Giovanni Principe speaking here, and I say you welcome to our webinar, because today we are going to, let's say, to see a lot of different topic, a lot of different stuff about our area sensors. I'm not alone here because a colleague of mine is going to support me. Is Giovanni Di Lorenzo.
Good morning.
Product manager in MD Micro Detectors, and today is going to answer to your questions. So if you have any doubts, if something is not so clear from my explanation, if you are curious and you want to deepen your knowledge about these products, do not hesitate to write your questions, addressing them to the Q&A profile, and Giovanni will be very, very happy to help you. Right?
Yes, correct.
Okay, thank you very much, Giovanni. So I think that now we are ready to start. So let's go on. Let's go on discovering in details what we are going to talk about during this lecture. First of all, we are having a brief picture of the technology at the basis of the working of these sensors. Then we can start exploring, in particular, each of all the series belonging to the area sensors family, starting from the CR retroreflective area sensors. And here I want to open, let's say, a brief parenthesis, because the CR retroreflective area sensors have been already treated by us during the previous lecture, the previous webinar we had some weeks ago. And I want to remind you that the recorded video of that lecture, as for all the lectures we have, is already on our YouTube channel. So I invite you to go online on our YouTube channel to see this lecture again if you lost some details, or if you lost this lecture at all, and to let your like let's say on the video itself. Then we are going to continue with the BX series, and in particular with the BX4, BX10, and BX80, because we are going to discover all the differences among these products. Then the CX0, the CX2, and finally the NX area sensors. Then we have a particular section where we want to share with you all the most significant and all the most interesting applications that we already solved thanks to our area sensors. And finally, as usual during our lectures, we have the practical part of this webinar, where we want to learn with you how to teach an area sensor, and in particular we are considering the BX10 product and the CX0 and CX2 series. So as you can see, this is a very, very full and wide lecture, but don't worry, because step by step we can explore and discover everything. So let's start with the first step. First of all, what about an area sensor? So how can we define an area sensor? An area sensor is basically an array of different photo elements which in general can be both emitters and receivers. But here we have to make a distinction between the retroreflective area sensors and the through beams area sensors, because the retroreflective area sensors work in the same way of a retroreflective monoray photoelectric sensor, in the sense that they emit a light beam which hits against a reflector installed on a wall in front of the sensor itself, and then this light beam comes back and it's detected by the reader, let's say. Within a retroreflective area sensor, we have, let's say, inside the same housing, the same box, we have more emitters and more receivers, following this scheme here, as you can observe in the picture. So emitter, receiver in alternate way. Within the retroreflective area sensors family, we have the CR0 and the CR1 series. And the main difference between them is based on their controlled area, because the CR0 has based on 6 beams, while the CR1, which can be considered as an extension of the CR0 product, is based on 14 beams. Another important, let's say, concept to be underlined is the beam pitch, which is the distance between two consecutive beams, two consecutive photo elements, and it's on the basis of the resolution that we want to achieve thanks to our sensor. And both in the case of CR0 and in the case of CR1, it's equal to 10 millimeters. Then, once we have talked about the retroreflective area sensors, we can face the through beam area sensors. So those area sensors where the emitters are separated by the receivers. So they are installed in two different bodies, in two different housings. So we have an array of emitters and on the other side, an array of receivers. As you can observe in our through beams area sensors with digital output, we use the cross beams detection. Why? Because in this case, we have a higher density in terms of light beams, so a high performance in terms of object detection. So the object passing through these two curtains are detected. On the other side, we have the possibility of using an analog output. And in this case, we have to cope with the parallel beams. In fact, in this case, we are measuring n height, and then we are going to see how we can measure it and the different variants that we can offer within our product portfolio. Okay, so now we can start with something we already talked about during the previous lecture, the retroreflective area sensor, so CR0 and CR1 series. And we can start basically from the common characteristics, so the features that are at the basis of both of them. So both of them are based on aluminum housing, are based on polarized beams, and these characteristics makes them able to detect also transparent object and object with irregular shape. Then they are able to detect the presence of target object till a maximum distance of 4 to 5 meters, with the possibility of adjusting them both in the fine and in the standard way. For what concern the output, we have both standard models with digital NPN or PNP outputs, with the possibility of selecting the normally closed or normally open logic, and also the IO-Link product. And if you go back to our previous webinar, you can discover that we talked a lot about the IO-Link communication on CR0 and CR1. So you, if you see again this that lecture, you can discover more about the advantages and the way of using this the IO-Link communication. Once we have described the common points, the common characteristics between the CR0 and the CR1, we can talk about a little bit of the differences between these two different products. First of all, the detection height, because the CR0 is based on 70 millimeters detection height, while the CR1, which is an extension of the CR0, is based on 149 millimeters. Then the minimum detectable object, which is equal to 6 millimeters at a distance of 2 meters for the CR0, while it's equal to 8 millimeters at the same distance for the CR1. And the switching frequency, which is equal to 400 Hertz for CR0 and 275 Hertz for CR1. But in any case, I want to underline the fact that it's a quite high switching frequency, very useful, very indicated for all of those applications at the board of conveyors where the high speed from sensors is required, is needed in order to, let's say, to cope with the high speed of the conveyor itself. Here, I, let's say, invite you again to see the webinar online about the CR0 and CR1, and I remind you that also this lecture will be recorded and then published in some days on our YouTube channel. Let's start now talking about the BX series, and we can start from the common characteristics, because as I said before, we have different products within these macro series. We have BX4, BX10, BX80, but basically they can be defined as compact area sensors. Why? Because they are all based on housing with a height of 120 millimeters and width of 20 millimeters with a length of 44. They are based on crossed beams detection, and as I said before, this can grant a higher performance level because of the higher density in terms of light beams. The sensitivity adjustment is performed by trimmer, and Giovanni will help us in understanding the procedure, the teaching procedure. And then we can start let's say, talking about the differences between the BX4 and the BX10. They are both based on detection height of 90 millimeters, but the BX4 is based on 30 millimeters in terms of optics step, which is the beam pitch, while the BX10 is based on 10 millimeters optic step. As a consequence, the BX4 has a minimum detectable object of 15 millimeters. On the other side, the minimum detectable object of BX10 is equal to 5 millimeters, so very small objects. Another difference is represented by the sensing distance, which is fixed if we talked about the nominal maximum range for the BX4, because it's equal to a range from 0.3 meters to 2 meters. while for the BX10 we can reach also 4 meter, 6 meter, and we have also, let's say, smaller range for applications where we need higher precision, from 100 to 350 millimeters. As you can observe, it is not just a matter of the maximum distance, but also the minimum detectable distance. This value here, 0.3 meters, means that within this distance, with distance lower than this value, the system, based on the emitter and the receiver, is not able to detect anything. It's based on the optical technology, is based on the correct alignment between the photo elements, between the emitters and the receivers. So you have to respect this minimum distance in order to catch the desired target object. Let's go on now with the BX80 series with a detection height of 70 millimeters and an optic step of 6 millimeters. This sensor is able to detect very, very small objects with a dimension of 2 millimeters. What about the sensing distance? We have models with a distance from 0.3 meters to 2 meters, and other models with a distance from 0.3 meters to 2.5 meters. In this case, we have that the emitter and the receiver are synchronized by wire, by cable. Since there are a lot of different applications, each of them with very specific requirements and let's say difficulties which can be related to the harsh conditions of the environment surrounding the sensor itself, we have developed some special models, so over the standard ones that we propose in our catalog. So for what concern all of those applications with a very high temperature, we have this BX model with an aluminum enclosure and an air cooling inlet system. What does it mean? It means that the standard product, the standard sensor, is included within this aluminum enclosure, and then we are introducing fresh air through this cooling inlet system in order to keep lower the temperature of the sensor and to grant the right working conditions, to grant that the electronics do not have some damages. This is very useful in applications like industrial furnaces, where you can imagine it's very hot. Another important special model is related to the possibility of connecting in a cascadable way more couples of BX sensors, so more couples of emitter and receiver without having any kind of interferences, because if you use standard BX models and you connect them in a very limited space, you have the risk of generating some interferences between, let's say, an emitter and a receiver of two different couples of sensors. In this way, you can, let's say, you can use all of your spaces, even if they are very limited. Another important product is represented by the IP69 key protection degree BX sensor. So a very resistant sensor, very robust sensor, which allows us to be present in some difficult, some harsh applications, like food application, like hygienic design application. And then during the application part, during the application section, we are going to see something about the usage of this special model. Another interesting special model is represented by the BX with high immunity to interference of external light. So imagine that you have to install your sensor on a machine near a window, and imagine during a sunlight day how much light can enter this window, and how much interference can be created with this sensor. In this way, the sensor is able to, let's say, not be influenced by these external disturbances. External disturbances still 100,000 lux. Also, in this case, we have some specific applications like metallurgic and steel sectors. Now, once we have, let's say, described in a very theoretical way the characteristics of BX4, 10, and 80 products, and we have seen something about the special models, we are ready to, let's say, to enjoy the practical part of this lecture devoted to the BX product. In particular, we are going to talk about the BX10 model and to learn how to face the procedure. First of all, starting from the alignment procedure, and then continuing with the trimmer adjusting. But Giovanni is going to show us all of those, all of these procedures. So please, Giovanni, you can go. The scene is yours.
Thank you. Now we are working with a BX10 model. We have emitter and receiver. And the first thing that I want to stress is the respect of the minimum working distance. In fact, the sensor, as Giovanni said before, has a minimum sensing distance of 0.3 meters. And now we see what happens if we go too close to the emitters. As you can see here, the output switch. So if we go too close, the output is activated. The reason is why? Because since this sensor works with a total beam crossing technology, each beam emitted by one of the emitters has to receive by all the receiver. If you are too close, some beam is missed, and so the sensor works as there is something in the middle, so the output is continuously switched. To adjust the sensor is very easy because we have a cover here on the emitter, and if we remove the cap, we see that there is a trimmer inside, and it is very easy to adjust the sensitivity. So we can adjust the sensitivity just turning in one direction the trimmer until it's switched, and then we can work, and so we can set the sensor to detect very small object. So we can work to detect also small object. To complete the presentation of the BX series, I want to show you the sensor with a special enclosure. So we have a metal enclosure, very robust, very tough, and with the plug for the air. So we can keep just adjusting the flow of the air inside the sensor the temperature of the sensor inside this cover, and so we can work even if the external temperature are very, very high. So for BX10 is enough, for big series is enough, and I pass again the speech to Giovanni to go on with the presentation. Thank you.
Thanks to you, Giovanni, for your clear explanation about the teaching procedure. So about how to teach BX10 sensor, and in particular we have seen how easy it is to adjust the power emission simply using a trimmer. Now we are ready to go on with the other series that we are studying today, the CX0 series. It is based on aluminum housing, like in the case of CR0 and the CR1, if you remember. And we have two kind of height within our variants, within our models. 160 millimeters and 320 millimeters, with the possibility of vary between 5 millimeters and 10 millimeters in terms of beam pitch. The operating distance, so the maximum distance we can reach, is equal to 6 meters. 3 meters if we want to achieve a better resolution, 5 millimeters resolution. Also in this case, like in the BX80, we have intrinsic synchronization by cable wire, high frequency and crossed beams, because as I said before, the crossed beams technique allows us to let's say to increase the density of light beams and to increase the performance in terms of object detection. Another point that we are going to deepen, let's say to treat in detail during the practical part later on, is represented by the auto setting function at the power on. It's a function allowing us to let's say to set the sensor, automatically setting the sensor on the basis of the environmental conditions when the sensor is powered on. And it's quite useful, but it's also dangerous if we, let's say, if we are not considering some conditions, some initial conditions, as Giovanni is going to show us during the practical part. So what about the LEDs indicators? And what we are going to say now is true also for the CX2 series. We have three kinds of indicators. The first one showing the power supply condition, and it is green for the emitter, it is blue for the receiver. The second one is the yellow LED, and it shows the emission for the emitter and the output state for the receiver. And there is the third one, the red LED, the diagnostic LED, which shows that some problem, some issues is present. So something we will not have is present. Okay, now we are ready, as you can observe in the video, we are ready to show you the teaching procedure for the CX0 models, and in particular the alignment and this fine and standard teaching. So I can leave again the scene and the speech to Giovanni, who is going to show us the procedure. So enjoy the procedure.
So Also in this case, we have an area sensor, in this case a 6.0 model. And as you can see, we have emitter and receiver, and they are very easily identified by the LED. So we have a blue LED on the receiver, while on the emitter, we have a green LED. So independently how to install your sensor, it's very easy to understand how the sensor is installed. Another feature is that also for we have LED indication on the top, on the bottom of the unit. So independently how to install the sensor, very easy to immediately to check how the sensor is working. Also for this model is important the minimum working distance, because if you are going too close, as you can see, the output switch. Also in this case, the sensor works with a cross-beam technology. So if you are too close, it's not possible for the sensor to receive all the beams. To adjust the sensitivity is very, very easy, because you have to just to connect the setting wire to positive or negative for the fine or gross teach-in, and immediately the sensor is set. So you can now see that the sensor adjusts its sensitivity according to the working distance. You can leave this wire normally connected to positive or negative, and so at each teach-in, as you can see, it's perform the setting procedure. Normally, we not suggest this procedure because you have to be sure that you don't have any kind of object in the middle. Otherwise, what happens is that the sensor tries to teach himself in any case, and so you can have some points where you have some lack of resolution. So the best thing is, once the setting is performed, to keep this wire not connected, so remove the connection to the ground or to the positive. Another important possibility is to set the sensor in normally open, normally close. Now you can see that the sensor is working in normally open, so is activated only when the target is present, but you can work as also as normally close. So you connect the setting wire to positive, and restarting the sensor, you see that now the output is activated. So the output disengage when the target is present. So this is a very easy way to adjust the sensitivity of the sensor, because it is very easy to adjust this this sensor, the 6.0 series. So for the moment, that's all, and I pass again the speech to Giovanni. Thank you, Giovanni.
Thanks to you, Giovanni, for the clear explanation, as always. In fact, you let's say make it possible to see how to teach a 6.0 product after having aligned the two elements, the emitter and the receiver. Then we have seen that the procedure, the auto setting procedure, could be useful, but as I said before, it's quite dangerous to base on it, because you should be very sure that nothing is present around the sensor. Okay, now we can go on with the 6.2 series. 6.2 series based always on aluminum housing, but with a lot of different height. starting from 160 millimeters till 960 millimeters. The beam's pitch could be 5 millimeters, 10 millimeters, or 20 millimeters on the basis of the resolution that we want to achieve. The maximum operating distance is equal to 6 meters. 3 meters if we want to achieve a resolution of 5 millimeters. Also, in this case, we have the intrinsic synchronization by cable wire, high frequency, and crossed beams detection system for the digital output, because for the analog outputs, we have the parallel beams detection. Also in this case, we have the auto setting function at power on, and we have also here the blanking function, so the possibility of obscure some optics, as we have seen, for instance, for the CR0 and CR1, where we were able to obscure some optics. In this case, for the CX series, we have both double digital outputs, so NPN plus PNP, double analog outputs, so current plus voltage, and mixed output, digital plus voltage. Okay, now just some clarifications about the analog output. So imagine we have we are considering the voltage output. What about this output? What about this value? We have a value expressed in volts, but what does it mean? If we consider standard models, as you can observe in the first row of the picture, the value is related to the height of the target object, despite its position in space. So you can observe here this package, which is at the ground floor in the first case, and the output is 5 volts. Then the same package is higher with respect to the ground, but the output is always 5 volts. It means that we are measuring, as I said before, the height of the package itself. On the other side, we could be interested in not in measuring the height of the object, but we could be interested in measuring the higher part of the object in our space. So if the package is at the ground level, we would want to see 5 volts. If the package is on another object or is let's say at higher height, we want to read this value. So in this case, 8 volts. The special model granting this kind of measuring is called top beam models. Okay, now we can go on with the third part, with the third practical part, where Giovanni is going to show us the analog output. In fact, you can observe the voltmeter in the video in order to show you the output in volts. And in particular, we want to show you the alignment, the teaching procedure, and the blanking function, so the possibility of obscure some optics. Okay, I think that Giovanni, you can take the scene. Thank you.
Thank you. Now we are working with the 6-2 series with mixed output. So in this case, we have a model with analog and digital output. And so the first thing is to switch on the sensor, and after a while the sensor is ready to work. So we can see that the output is activating. While in the previous mode, in the 6.0 mode, we have only the digital output, we have also in this series the possibility to have analog output. So an output that gives us not only information regarding that the target is present, but also regarding how many optics are obscured by the target. We can work in also like in the previous model in normally open and normally closed. So the procedure is the same, connecting the selection wire to positive and restart the model. After a while, we can see that the output now, digital output now is activated, but also we see that also the analog output is working in a reverse mode. So now we are working from 10 to 0 volt, while in the normally open or positive ramp, we see that we are working from 0 to 10 volt. Also, the adjusting procedure is the same of 6.0. You have just to connect the teaching wire to positive or negative for the gross or the fine teaching, and restart the model. So we can, after a while, we see that the teaching wire will be completed and the sensor is working in the correct way. The time is slightly longer than the previous model because we have a lot of things to do inside the sensor. So also in this case, we have adjusted the sensitivity of the sensor. Differently from the previous model, we have also the blanking function available on this model. Blanking function is useful when you have a fixed part of your machine just in the middle of the optic space. So if you have a mechanical part of your machine in that position, with a standard sensor is not possible to work. In this case, we can set the blanking function. So connect the blanking wire to positive, restart the unit, and also in this case, the unit is adjusting its sensibility in a way to work in the correct way. After now, you can see that the sensor now works without any problem, even if the object, we have a metal part in the middle. It is very important to remind that if this part is removed, you have to adjust the no blanking function, because otherwise we see that now we have a hole inside the sensor. So the solution is to connect the blanking wire to the ground, restart the sensor, and the sensor now canceled the blanking function that we have set in the with the previous connection. So after a while, the sensor is now working to work, and now we don't have any blanking LED, so we can work and restart to work in a simple way. So again, make the teach-in because after installation and after each changing in resolution, so if we set the blanking function, the first thing to do is always to make a reset of the sensitivity, and so we can work. So that's all for the moment, and again I pass the speech to Giovanni. Thank you, Giovanni.
Thanks to you, Giovanni, for this other clear explanation of the teaching procedure of CX2 sensors. I me too, I did not imagine it was so simple to teach this product, because despite the appearances which could show a product which is complicated, in other words, we can see that the teaching procedure, it's quite easy. So please notice this point, because with these sensors you can solve very complex applications in a very easy way. Now we can go on with the NX models, which are the models without housing. So you can ask why I have a sensor without housing. Why should I think about a sensor without housing? The answer is strictly related to the necessity, to the applicative necessity of doing that. In fact, I invite you to read the first line. These products have been designed for vending machine applications. It means that we had to solve the problem related to the limited space, so to have a compact sensor. And how to develop a compact sensor? Simply by eliminating the housing. Basically, this sensor is just a PCB with all of its electronics inside and all the optics connected, not more. In particular, we have models with 14 optics and models with 16 optics. It depends on the standard of our vending machine, with an operating distance from 0.37 to 2 meters and a resolution very, very high, 1 millimeter. Why? Because you have to detect any kind of objects falling down from a vending machine. Models, let's say, can be adjusted through a teaching procedure. Let's move on now to the applications section, where we want to share with you the most significant applications that we already solved thanks to our area sensors. First of all, we can use the CX products to detect the passage of very, very small and thin objects, like, for instance, the mechanical parts coming out from a molding machine, as you can observe in this picture. Then, for what concerns the CX2 series with analog output, we can use them in order to analyze the profile of some packages passing on a conveyor. So we can measure the height of a package passing through the emitter and the receiver on a conveyor. And as I said before, thanks to the top beam models, you can also follow the package itself, also if it is not at the ground level, at the level of the conveyor itself, but if it's, let's say, located in other positions. Then, within the special models, we have seen the BX sensors with IP69 key protection degree. I said you that they were for the food and hygienic design applications. Like in this case, when we use them on an automatic line for vegetables or also for seafood products. Why? Because in these machines, we have a lot of washing procedures, washing of the mechanical parts of the machine itself. And so we have to let's say, protect the sensor, protect the electronic inside the sensor. And in this case, the mechanical protection degree can grant a very high resistance, very high robustness of the sensor. The other application that we want to share with you is the usage of BX area sensors to detect the presence of panels before the let's say the process of plastic wrapping. so in the wrapper machine. Unfortunately, we reached the end of this, let's say, interesting lecture. So it's time to have a brief recap of what we have learned, of what we have seen. First of all, we have seen something about the technology, so how an area sensor works. Then we have started to explore the main characteristics of this kind of area sensors, CR0, CR1, which are the retroreflective area sensors, BX 41080, CX0, CX2, NX sensors for the vending machine applications. Then we have seen something about the applications, and thanks to Giovanni, we have explored how to the teaching procedures regarding the BX10 products and the 6062 series. Of course, it is not enough. We have not finished talking about the area sensors because a lot of other things needed to be said. As a consequence, I invite you to write us at info@microdetectors.com if you have some doubts, if you want to clarify something, if you are curious and you want to deepen your knowledge about these products, but also if you want to provide us with your precious feedback about the webinar itself. I also invite you to visit our website, microdetectors.com, in order to discover what's going on. And please subscribe to our YouTube channel and follow us on LinkedIn. In fact, I remind you again that all of our lectures are recorded and they are published some days later on our YouTube channel. So if you lose some passages, if you lose some details, you can see it again online. Thank you very much for your time, for your precious time and your precious attention, and see you soon at the next webinar. Bye-bye.
Bye, thank you.